thing that we want to see is what is called as Coulomb's law. We know that when there are two charges, they either attract or they repel. If it's two same charges, they're going to repel. If they are two different charges, then they're going to attract. So there's a force of attraction or repulsion between charges, depending on what kind of charges they are. For example, let's say there are two charges, both of them are positive. Clearly, they're going to repel each other, isn't it? Can we know what is this force of repulsion? So force is a vector, right? It has a magnitude and it has a direction, right? So what is the magnitude of that force and what's the direction of that force? Direction, very obvious, right? When you have two charges which are both positive, they're going to repel. So the direction of forces is going to be simply in this direction. But why do we indicate two forces here? Pretty interesting, right? Because the charge Q1 has a repelling force on Q2. So Q1 is going to push Q2 away, all right? Similarly, Q2 is going to push Q1 away. So the convention that we follow is the source is here, the force due to 1 on 2. The force due to 1 on 2 is F12. Due to 1 on 2, yeah? That's the convention we follow so that you don't get wrong with the signs of the force, yeah, the direction of the force, because one force is opposite to the other. So then you have F21, which is the force due to 2 on charge 1. So that's the convention you want to follow, the subscript for the force. So we know the direction, right? Now, what about the magnitude? The magnitude turns out that it's proportional to Q1 and Q2, the amount of charge. How much is the charge, Q1 and Q2? And inversely proportional to the square of the distance between them. That means closer they are, higher the force, but as r becomes very much, then the 1 over r square is going to go very low. Yeah, is going to be a very low value as they get separated out further and further. If they are too far away, that value of the force is going to be so low that this force is not going to have any influence on the other. Only when they are very close to each other, this force is going to be very high. Obviously, see now that if my Q1 was positive and if my Q2 was negative, if Q1 was positive and Q2 was negative, like what you see here, then all the changes is the direction of the force. The magnitude remains the same. What used to be in this direction now has become in this direction. Only the direction of the force has changed. And then we say that this is proportional, right? So there's a constant of proportionality, and that constant of proportionality depends on the material property of the medium. It has this 1 over 4 pi epsilon naught, where this epsilon naught, that epsilon 0 is 8.854 into 10 power minus 12 farad per meter. Okay, that it's a constant, which is 1 over 4 pi epsilon naught, and it's called permittivity of free space or air, yeah, space or air around us. Clearly, the force by Q2 on Q1 is going to be F21 is in the negative F12, right? So it's going to be equal and opposite. This is in agreement with Newton's third law of motion.